Most welcome, David 7 Science Theater. You can contact us using the gmail.com, and you can. Today we're going to talk about synthesis of steroid hormones. Basically, this video has concentrated on the synthesis, but we have more videos that have more about steroid hormones. You go subscribe and look for them. Then about synthesis, we are going to talk about correlations as well. The correlations, clinical correlations. Okay, that is the Science Theater, David 7. Don't forget to like here. Things are extremely good. You subscribe for more and better videos. Then you share to other students and other people to also enjoy the science. Okay, so steroid hormones, we have a group 1 hormones. Group 1 hormones, these are hormones which they act by their effect on gene expression. They include steroid hormones, retinoids, and thyroid hormones. These hormones are lipophilic in nature and can easily cross the cell membrane. They act through intracellular receptors located in cytosol or nucleus. So now, the steroid hormones are basically these four. We have the glucocorticoids like cortisol. We have the immunocorticoids like corticosterone, like aldosterone. We have the sex steroids like testosterone, and we have the vitamin D. That is also steroid hormones. They are derived from cholesterol. Okay, the glands which release the steroid hormones, we have gonads, have placenta, and we have adrenal cortex. These ones synthesize the steroid hormones. Okay, for example, corticosteroid hormones are synthesized from cholesterol, which is actively taken up by adrenal cells from the low density lipoproteins in blood. Yeah, when you have LDLs in blood, adrenocytes take up these LDLs and they synthesize the corticosteroids from that cholesterol. Now look at this. This is what I've been talking about. The liver gives you VLDLs. When they reach the blood, VLDLs, there is a transfer of cholesterol and tags. Cholesterol is from HDL into VLDLs to form the LDLs. So the VLDLs just give tags to HDL. So this cholesterol, when it goes to VLDLs, they form LDL. It's the same apoprotein, and this one is the one which continues to the glands for synthesis. HDL is just from extrahepatic tissues carrying the cholesterol in high quantity. Okay, all have a steroid nucleus, i.e., have ring A, ring B, ring C, or ring D. These are basically what form the steroid nucleus. And you can see the numbering. When I talk about 11, is here. So it is 1, 2, 5, 6. Now it goes 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. So 18 and 19, they are just those methane carbons, yeah, methyl carbons. Okay, let's continue. Cholesterol. Cholesterol, after entering into the cell, most of the cholesterol is stored as cholesterol ester. So under basal conditions, corticosteroids are synthesized from free plasma cholesterol. But when the production is stimulated by STH, the stored esterified cholesterol becomes the most important precursor, which is hydrolyzed by cholesterol esterase. The free cholesterol in cytosol then enters the mitochondrion. So that is it. Most of cholesterol is stored as cholesterol ester. That is true. Corticosteroids are synthesized from free plasma cholesterol. Yeah. But when there is this hormone, the most important precursor are the esterified cholesterols in the cytosol. Yeah, okay. Look at this. I want us to go through the synthesis. Let me first talk about these enzymes. We have HSD, which means hydrosteroid. Yes, it means we have HSD. I'm gonna be using them, so you need to know the definitions of. We have HSD, which means hydrosteroid dehydrogenases. Aromatase is an enzyme that converts the testosterone to estrogens. Yeah, it converts the testosterone to estrogens. Then we have hydroxylases, which add just one oxygen atom to the hydrogens of specific carbon. So when it is H, it becomes OH, hydroxylases. Add an oxygen atom. Then we have the 22 decimales. This is just cytochrome P11 A1 in mitochondria. It cleaves the side chain between carbons 20 and 22. Cleaves that side chain. That is a desmolase. Desmolase is usually cleave of the side chain. They cleave off a segment of carbons. Okay, look at this now in synthesis. When you have cholesterol like this one, this cholesterol, you have a desmolase which will cleave off the side chain. Cholesterol has 27 carbons. So the side chain between 20 and 22 will be cleaved off. When it is cleaved off, remain with a ketone group, yeah, like this one, and that is what we call progenenolone. All other things are similar, just that part side chain goes off, so remain with progenenolone. Then we have that is desmolase. Now, if we want to synthesize something like look at this. If we want to make something like, let me say, aldosterone, we shall use 3-hydrosteroid dehydrogenase, which removes the hydrogen at carbon number 3, as you see there, and we form progesterone. Progesterone is a precursor of many things, yes, but look at this. It can give us the cortisol, it can give us the testosterone, it can give us the aldosterone. So we have progesterone, which will be when we use enzyme 21 hydroxylase, it makes carbon 21 hydroxylated, yes, such that it was a methyl group, it becomes an alcohol. So this is deoxycorticosterone, yeah. Now we have corticosterone formed by 11 hydroxylase, yes, and that is adding O at carbon 11. Then we form hydroxycorticosterone by 18 hydroxylase. Then we end up with 18 hydroxysteroid dehydrogenase, which dehydrogenases carbon number 18, and it makes it an aldehyde, which you call aldosterone. So basically, it moves like we have from progesterone to form aldosterone, you need 21, 11, 18 hydroxylases and 18 hydroxysteroid dehydrogenase. Yeah, 21, 11, 18. Now, if you want to form something like cortisol, you'll need 17 hydroxylase, 21 hydroxylase, and 11 hydroxylase. 17, 21, 11. This was 21, 11, 18. This is 17, 21, 11. So those hydroxylases, when you hydroxylate progesterone, get hydroxyprogesterone. So here you form deoxycortisol, and you end up having cortisol. So this is the cortisol. It has a hydroxyl group here, a ketone. It has hydroxyl groups, several hydroxyl groups, 11. Okay, so that is cortisol. Now, if you want to form something like testosterone from progesterone, use 17, then a desmolase, which is 1720, to cleave off this side chain, 1720, and you will form androstenedione, and finally you'll get this 17 hydroxysteroid dehydrogenase to form testosterone. Aromatase will convert that testosterone to estradiol. So basically that is it. Maybe another point is that we are capable of forming the testosterone right from progesterone using the 17 hydroxylase, then the 17-20 decimolase to form dehydroepiandrosterone. So this is an androgen usually released by the zona. And to note is about the changes in the position of this double bond, this pi bond. You can see you can see here, yeah, in pregnenolone, have a double bond between, this is carbon 5 and 6. In progesterone, this is 4 and 5, yes. This change comes about as you lose the hydrogen atom here by dehydrogenase. So the position of the double bond changes. In this one, the double bond is the same. We have not lost any hydrogen atom. So that is another point to note, maybe. And I was talking about, yeah, that is basically what we need to know. Let's continue. Functions of synthesized hormones. One, if you talk about cortisol, cortisol maintains muscle function and decreases muscle mass. You see this one produced during stress. Then cortisol decreases bone formation and increases bone resorption. Yeah, resorption is by the osteoclasts. Then the cortisol decreases connective tissue, comes along with stress. Then cortisol modulates emotion, tone, and wakefulness. You are very awake during stress, and stress people rarely sleep. Yeah, and cortisol maintains cardiac output and increases arteriolar tone. It decreases endothelial permeability of the blood vessels. Okay. Cortisol inhibits inflammation and immune response. We shall talk more about this. Yeah. Cortisol facilitates maturation of the fetus. This is a good point to note. It increases glomerular filtration and free water clearance. Yeah, that is cortisol. Those are the basic functions of cortisol. When they ask you for some 6, you can be able to give some 6 from here. It inhibits inflammation and immune response. Let's continue. We want to talk about the anti-allergic and anti-inflammatory roles of cortisol. Look at this. If I just say these are the sites of action of cortisol in inhibiting the inflammatory response, at this point, during inflammation, we usually produce platelet activating factor and nitric oxide during inflammatory response. Also produce phosphatidylcholine, arachidonic acid using the enzyme phospholipase A2, which cleaves it from phosphatidylcholine, and this is at position 2 here of this phospholipid in the membrane. So we cleave off and form arachidonic acid. So the cortisol inhibits this enzyme, so no formation of arachidonic acid. It will inhibit formation of dilator and formation of platelet activating factor. So it means there will not be vasodilation, permeability will reduce, and even the leukocyte trapping is affected. This arachidonic acid usually is converted to prostaglandins and thromboxanes. So cyclooxygenase, which is responsible COX enzymes, are inhibited by the same enzyme, by the same hormone cortisol. So it means even these effects here are affected: the vasodilation, permeability, and leukocyte trapping. Arachidonic acid can be used to form leukotrienes, which are important in the function of the neutrophils, which are phagocytic and bactericidal. So it means if we inhibit here by using cortisol, phagocytosis reduces. Okay, let's continue. Cortisol on immune response. How does cortisol affect immune response? Basically, look at this. We have an antigen. Stimulus macrophages produce interleukin 1. So it inhibits this step here. The same cortisol inhibits formation of fever. This is interleukin 1 are responsible for activating T cells such that release interleukin 2 and 6. So it inhibits formation of IL-2 and 6. Also, tumor necrosis factor is not produced. The interleukin 2 and 6 are responsible for T cell proliferation and increasing the number of B cells. So this does not occur perfectly due to cortisol produced during stress. Therefore, antibody production will reduce. Yes, that is it. So the clinicals, I want to talk about Cushing syndrome, what we call the hypercortisol state, when you have a lot of cortisol in the body. Cushing syndrome. This refers to a group of clinical conditions occurring due to prolonged excessive levels of cortisol or glucocorticoids. It can be STH dependent or STH independent. Recall this is adrenal corticotropic hormone. It means it activates the adrenal cortex to start secreting hormones. So if it is dependent, that is ACTH dependent Cushing syndrome. Okay, so now we have 80% of the cases here and occurs due to hyperplasia of adrenal cortex so that it secretes excessive cortisol caused by excess of STH. So it means the STH is in excess, causing hyperplasia of the adrenal cortex. Hyperactivity of pituitary is seen in tumors of pituitary cells, particularly basophils, which secrete the STH. The resulting condition of pituitary origin is also called Cushing's disease. So Cushing disease has occurred when there is hyperactivity of the pituitary gland. Yeah, this is the cause of excess STH produced. Okay. Now another cause, well, we have like ectopic STH production, as seen in benign or malignant non-endocrine tumors, e.g. cancers of the lungs and abdominal viscera. So if we have production of STH in other tissues other than the pituitary gland basophils, that is ectopic. So it is another cause of hyperplasia and hypercortisol state. Okay, we can have excessive STH secretion when there is a disorder in the hypothalamus associated with excessive cortical releasing hormone. Okay, so this one is the one which the releasing factor which stimulates the pituitary produce STH. So when it is in a high in disorders of the hypothalamus, we end up having hyperplasia of the cortex and and the cortisol increases, causing Cushing syndrome. Group of conditions. Let's continue. You can have iatrogenic, where you are taking the therapy of STH but in excess. Okay, right. It can be STH independent Cushing and is less common, like 20% of the cases. What is the cause? Adrenal origin Cushing syndrome is caused by glucocorticoid secretory tumors such as adenoadenoma or carcinoma. So that is it. If you have recurrence of the adrenal cortex, which is not STH dependent, you'll end up having hypercortisol state. And you have excessive glucocorticoid administration. Some people give themselves more cortisol or excess cortisol as a therapy, and they end up having hypercortisol state and associated clinical syndromes. The effects and manifestations of hypercortisol state. Look at this. Truncal or centripetal obesity. Yeah, that is one. You have obesity, a lot of fat is deposited around the trunk. Yeah, there is fat redistribution. Recall cortisol causes increased fatty acids mobilization. So they will be redistributed from storage areas of adipose to around this trunk. Yes, you can have deposited at the back of your body to form a hump. Yeah, then you can have a bull hump, like a bull hump. Then you can have deposition around the trunk, as you see this peak here. Muscles will become weak, because cortisol increases protein degradation, so the muscles will become weak. And the sodium and water retention may cause weight gain, edema, and hypertension. Yeah, during high cortisol, you retain a lot of sodium, and therefore you can get edema and hypertension. Another effect and manifestation is the hyperglycemia, which occurs during the hypercortisol stage. You get? So, uh, this hyperglycemia is not good, has a lot of associated effects. You have a lot of glucose in blood. The fifth is the asceticism and menstrual irregularity may occur due to increased adrenal androgens. The menstrual cycle becomes irregular. Yeah. Number 6, you are susceptible to osteoporosis and bone fracture. Recall proteins are being degraded and bone is majorly protein, collagen. So it means you will be exposed to osteoporosis or bone fracture. 7, you are susceptible to infections. As you have low proteins, it means your immune system gets weak. Antibodies require a lot of amino acids, yes, to form antibodies. So you are susceptible to infections. There are psychological, emotional, and personality changes. Your skin will blacken just because the STH released in excess has a MSH, that hormone MSH, which causes blackening of the skin. So it has an effect similar to that hormone's effects, and the end result will be hyperpigmentation. Then we have susceptibility to peptic ulcerations is increased, yeah, or occurring during hypercortisol stage. Let's talk about okay, you can find more about aldosterone and sex steroids in the next video. Yeah, but if I'm talking about the adrenal cortex, just to revise with you, adrenal cortex has the glomerulosa, which produces mineralocorticoids like aldosterone. We have zona fasciculata, which produces the glucocorticoids like cortisol. Then we have reticularis, produces androgens like dihydroepiandrosterone. This one here, DHEA. Then we have adrenomedulla, which secretes catecholamines like epinephrine and norepinephrine by the chromaffin cells. You get? Okay, so that is secretion. Adrenomedulla gives us the catecholamines, and you can note the pheochromocytoma when there is a cancer of the medulla. Yeah, thanks for watching. Thanks for liking the video. You like the video, you subscribe for more and better videos. And lastly, you can share to other friends, share to your fellow students, share to your students, share to everyone to enjoy the science. Okay, we love you.